What if the world you see, the air you breathe, and even the thoughts in your mind aren't real? What if everything around us, every star in the sky, every atom in your body, is nothing more than lines of code in an unimaginably advanced simulation? It sounds like science fiction, but what if it's not? What if the universe itself is a simulation, and we're all just characters in a cosmic video game? In this video, we're diving deep into one of the most mind-bending questions of our time. Could the universe be a simulation? We'll explore 30 fascinating ways this could be true, from the pixelated fabric of reality to the eerie precision of mathematical laws that govern everything. Along the way, we'll uncover scientific theories, philosophical ideas, and possibilities that will challenge everything you think you know about existence. So, buckle up. By the end of this journey, you might just find yourself questioning the very nature of reality. Are you ready to uncover the secrets of the universe? Let's begin. Now, let's zoom way into the very fabric of reality itself. Imagine the universe as a vast, intricate video game. Just like the graphics in your favorite game, what if reality is made up of tiny, indivisible pixels? This is the idea behind the pixelated universe. At the smallest scales, the universe might not be smooth and continuous, but instead, it could be made up of discrete, finite units, much like the pixels on a screen. This concept isn't just science fiction, it's rooted in the strange world of quantum mechanics. Scientists have discovered that space and time might not be infinitely divisible. Instead, there's a smallest possible unit of length known as the Planck length. To give you an idea, the Planck length is so small that if you were to magnify an atom to the size of the observable universe, the Planck length would still be smaller than a single atom. It's the universe's version of a pixel, a fundamental building block of reality. But why does this matter? Well, if the universe has a smallest unit of space and time, it suggests that reality might be digital at its core. Just like a video game renders its world using pixels, the universe could be running on a kind of cosmic code. This idea isn't just speculative, it's supported by the bizarre behavior of particles at the quantum level. Particles don't behave like smooth, continuous objects. Instead, they jump between states almost as if they're being processed by a computer. So, what does this mean for us? If the universe is pixelated, it could be evidence that we're living in a simulation, a digital reality created by some unimaginably advanced civilization. The Planck length might be the resolution of the simulation, and quantum mechanics could be the software that makes it all work. It's a mind-bending thought, but one that's grounded in real science. As we move forward, we'll explore even more ways the universe might be a simulation. But for now, let's sit with this idea. What if the world around us, down to its very core, is made of pixels? What if reality is just a cosmic video game, and we're all players in the ultimate simulation? The answers might be closer than we think. Now, let's shift our focus to something equally fascinating: the idea that the universe might be running on a set of mathematical rules so precise, it's almost as if it were programmed. Think about it. The laws of physics, the constants that govern everything from the speed of light to the force of gravity, are so finely tuned that even the slightest change would make life as we know it impossible. This level of precision has led some to wonder, could the universe be a simulation with these mathematical laws acting as its underlying code? Take the speed of light, for example. It's not just any random number, it's exactly 299,792,458 meters per second. This isn't a rough estimate or an approximation. It's a fixed, unchanging value that plays a critical role in how the universe operates. Similarly, the gravitational constant, which determines how objects attract each other, is so precisely calibrated that even a tiny deviation would throw the cosmos into chaos. Stars wouldn't form, planets wouldn't orbit, and life as we know it couldn't exist. This kind of precision is hard to explain as a random accident. It's almost as if these constants were carefully chosen, like the settings in a computer program. In fact, some scientists and philosophers argue that the mathematical nature of the universe is one of the strongest hints that we might be living in a simulation. After all, if the universe were a program, it would need a set of rules to function, and what better way to define those rules than through mathematics? But here's where it gets even more intriguing. Mathematics isn't just a tool we use to describe the universe, it seems to be the language the universe itself speaks. From the spirals of galaxies to the patterns of snowflakes, mathematical principles appear to be woven into the very fabric of reality. This has led some to speculate that mathematics isn't just a human invention, it's the operating system of the cosmos. So, what does this mean for us? If the universe is governed by mathematical laws that are unnaturally precise, it could be evidence that we're living in a simulated reality. These laws might be the code that keeps the simulation running smoothly, ensuring that everything from the smallest atom to the largest galaxy behaves exactly as it should. It's a thought that challenges our understanding of reality itself, but one that's hard to ignore when you consider the numbers. As we continue to explore the mysteries of the universe, keep this idea in mind. What if the precision of mathematics isn't just a coincidence, but a clue that we're part of something far more extraordinary? The answers might be hidden in the numbers themselves. Now, let's take a step into the strange and unexplained, those moments when reality seems to glitch, leaving us questioning what's real and what's not. Have you ever experienced déjà vu, that eerie feeling that you've lived a moment before, even though you know you haven't? Or maybe you've heard stories of objects disappearing and reappearing in places they shouldn't be. These oddities, often brushed off as quirks of the mind or coincidence, might actually be clues pointing to a simulated universe. Think of it like this: if the universe were a simulation, it wouldn't be perfect. Even the most advanced software has bugs or glitches. So, what if these strange occurrences are the equivalent of errors in the code? Déjà vu, for instance, could be a momentary hiccup in the simulation, a brief overlap of memories or experiences that weren't meant to sync up. It's as if the program stuttered, giving us a glimpse of something that wasn't supposed to happen. Then there are the more dramatic anomalies like the Mandela effect, where large groups of people remember events or details differently from how they actually occurred. For example, many people swear they remember Nelson Mandela dying in prison in the 1980s, even though he was released and lived until 2013. Could this be a case of the simulation being updated or altered, leaving behind traces of the old version in people's memories? It's a wild idea, but one that's hard to dismiss when you consider how widespread these shared false memories can be. Even in science, there are phenomena that defy explanation. Take quantum mechanics, for example. Particles can exist in multiple states at once, or instantly influence each other across vast distances, actions that seem to break the rules of classical physics. Some researchers suggest that these quantum oddities might be evidence of a simulated reality, where the rules can bend or even break under certain conditions. It's as if the simulation is cutting corners to save processing power, allowing for behaviors that wouldn't make sense in a purely physical universe. Pop culture has also embraced the idea of glitches in reality. Movies like The Matrix and Inception explore the concept of a simulated world where the boundaries of reality can be manipulated or broken. These stories resonate with us because they tap into a deep-seated curiosity. What if the world we know isn't as solid as it seems? What if the cracks in reality are actually windows into the truth? So, the next time you experience something that doesn't quite add up, whether it's a fleeting sense of déjà vu or a story that everyone remembers differently, consider this. What if these glitches aren't just quirks of the mind, but signs that the universe itself might be running on code? It's a thought that turns the ordinary into the extraordinary, inviting us to question the very nature of reality. And as we move forward, we'll explore even more ways the universe might be hiding its true nature right under our noses. Now, let's shift our focus to one of the most compelling arguments in favor of a simulated universe, the simulation hypothesis, famously proposed by philosopher Nick Bostrom. This idea doesn't just suggest that we might be living in a simulation. It presents a logical framework that forces us to consider the possibility as almost inevitable. Bostrom's argument revolves around three key scenarios, each of which leads to a startling conclusion about the nature of our reality. First, let's break it down. Bostrom's hypothesis starts with the assumption that future civilizations will have the technological capability to create simulations so advanced that they're indistinguishable from reality. If that's the case, he argues, one of three things must be true. The first possibility is that civilizations capable of creating such simulations will go extinct before they can develop the technology. In other words, they'll destroy themselves, whether through war, environmental collapse, or some other catastrophe, before they ever get the chance to simulate entire universes. The second possibility is that these advanced civilizations, while capable of creating simulations, simply choose not to. Maybe they lose interest in running simulations, or perhaps they decide it's unethical to create conscious beings within a simulated reality. If this is the case, then the likelihood of us living in a simulation drops significantly. After all, if no one's running simulations, then we're almost certainly living in the base reality. But here's where it gets fascinating. The third possibility is that at least one advanced civilization does create simulations, and not just one, but countless numbers of them. If that's true, then the odds shift dramatically. Think about it. If there are billions of simulated realities and only one base reality, the chances of us being in the base reality become vanishingly small. In fact, Bostrom's argument suggests that if the first two possibilities aren't true, then we are almost certainly living in a simulation. This isn't just a thought experiment, it's a mathematical probability. Bostrom's hypothesis forces us to confront the idea that our reality might not be as solid as it seems. It's a humbling thought, isn't it, that we could be living in a simulation created by some advanced civilization, perhaps as part of an experiment, a form of entertainment, or even a historical reenactment. What's even more intriguing is how this hypothesis ties into other ideas we've explored, like glitches in reality or the fine-tuning of the universe. If we are living in a simulation, it would explain why the universe seems so perfectly calibrated for life because it was designed that way. It would also give us a framework for understanding those strange anomalies that defy explanation, like déjà vu or the Mandela effect. Could these be artifacts of the simulation, little clues left behind by the programmers? As we continue to explore the possibilities, one thing becomes clear. The simulation hypothesis isn't just a wild idea, it's a serious philosophical argument that challenges our understanding of reality itself. And as we move forward, we'll dive even deeper into the evidence and theories that make this idea so compelling. So, what do you think? Are we living in the base reality, or are we part of something much, much bigger? The answer might be closer than we think. Now, let's take a closer look at one of the most mind-bending phenomena in physics, quantum entanglement. This strange and fascinating behavior of particles could hold the key to understanding whether our universe is a simulation. Quantum entanglement occurs when two or more particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. It's as if these particles are communicating faster than the speed of light, defying our everyday understanding of space and time. So, how does this tie into the idea of a simulated universe? Well, think about how a computer program works. In a simulation, information doesn't need to travel through physical space, it's all processed within the system. If our universe is a simulation, quantum entanglement could be a feature of the underlying code. Instead of particles being physically connected, their behavior might be governed by the rules of the simulation, allowing them to communicate instantaneously because the system itself handles the information transfer behind the scenes. This idea becomes even more intriguing when we consider the implications for the nature of reality. If quantum entanglement is a programmed feature of a simulated universe, it could explain why particles behave in ways that seem to defy classical physics. It's like the simulation has shortcuts or optimizations built into its code to make it run more efficiently. These shortcuts might allow particles to know each other's states without needing to send signals through space, much like how a video game might render only what the player sees to save processing power. But what does this mean for us? If quantum entanglement is evidence of a simulated reality, it challenges our understanding of what's real. It suggests that the universe might not be as independent or objective as we think. Instead, it could be a carefully constructed system where everything is interconnected at a fundamental level, governed by rules that we're only beginning to uncover. This idea also raises questions about the limits of the simulation. If entanglement is a feature of the code, could there be other programmed behaviors we haven't discovered yet? And if so, what would that tell us about the creators of the simulation? Are they testing the boundaries of their creation, or are we simply observing the natural quirks of a system designed to mimic reality? As we continue to explore the mysteries of quantum entanglement, one thing is clear: it's a phenomenon that doesn't just challenge our understanding of physics, it challenges our understanding of existence itself. Whether we're living in a simulation or not, the implications of quantum entanglement force us to rethink what we know about the universe and our place within it. So, what do you think? Could this strange connection between particles be a clue that we're part of something far more complex than we ever imagined? The answer might just lie in the quantum realm. Now, let's shift our focus to another fascinating concept that could hint at a simulated universe: the holographic principle. This idea suggests that all the information in our three-dimensional universe might actually be encoded on a two-dimensional surface, much like a hologram. Imagine a holographic image where a flat surface contains all the data needed to project a three-dimensional picture. In the same way, the holographic principle proposes that the entire cosmos, with all its stars, galaxies, and even us, could be a projection from a two-dimensional boundary. So, how does this connect to simulation theory? Think about how a computer stores and processes information. In a simulation, the world we experience is essentially a rendering of data stored in a system. If the universe operates like a hologram, it could mean that the vast complexity of our three-dimensional reality is being generated from a simpler, two-dimensional code. This would be an incredibly efficient way to run a simulation, as it reduces the amount of data needed to create the illusion of a fully immersive, three-dimensional world. The holographic principle also aligns with some of the most cutting-edge ideas in physics, particularly in the study of black holes. Scientists have discovered that the information about everything that falls into a black hole might be encoded on its event horizon, the two-dimensional boundary surrounding it. This discovery has led to the idea that the universe itself might function similarly, with all the information about our reality stored on a cosmic scale boundary. If this principle holds true, it could mean that our perception of space and time is just that, a perception. The universe might not be as three-dimensional as it appears, but rather a projection from a simpler, more fundamental layer of reality. This would be a game-changer for simulation theory, as it suggests that the universe could be running on a kind of cosmic hard drive, where the data for everything we see and experience is stored in a compact, two-dimensional form. But what does this mean for us? If the holographic principle is correct, it challenges our understanding of reality at its core. It implies that the universe is far more interconnected and interdependent than we ever imagined. Just as a hologram relies on every part of its surface to create a complete image, our reality might depend on every piece of information encoded on this two-dimensional boundary. This could mean that every action, every event, and every particle is part of a vast, interconnected system, a system that might just be the code of a simulation. As we explore the holographic principle, we're forced to ask deeper questions about the nature of existence. Is the universe a projection from a simpler reality? And if so, what does that say about the creators of the simulation? Are they working within the constraints of a two-dimensional code, or is this just one layer of a much more complex system? The answers to these questions could reshape not only our understanding of physics but also our place in the cosmos. So, what do you think? Could the universe be a hologram? And if so, what does that reveal about the true nature of reality? The holographic principle might just be the key to unlocking one of the greatest mysteries of all. Now, let's turn our attention to another intriguing possibility: computational limits. If the universe is a simulation, it would likely operate within certain constraints, much like any computer program. One of the most striking examples of this is the speed of light. In our universe, nothing can travel faster than light, which acts as a kind of cosmic speed limit. But why would such a limit exist? If the universe were a simulation, this could be a way to manage the computational load. Just as a computer can only process so much data at once, a simulated universe might have built-in limits to prevent the system from being overwhelmed. Another example is Planck time, the smallest unit of time that has any physical meaning. It's so tiny that it's almost impossible to comprehend, about 1/10 million trillion trillionth of a second. This incredibly short timescale could represent the frame rate of the universe, the smallest interval at which the simulation updates. If the universe were a video game, Planck time would be the time between each frame, ensuring that everything runs smoothly without glitches. These limits aren't just random rules, they could be clues about the underlying system running the simulation. For instance, the speed of light might be a way to prevent information from traveling too quickly, which could cause errors or inconsistencies in the simulation. Similarly, Planck time could ensure that the universe operates in discrete, manageable steps, rather than requiring infinite computational power to process continuous changes. But what does this mean for us? If the universe has computational limits, it suggests that the simulation is running on a finite system, one with boundaries and constraints. This raises fascinating questions about the nature of the simulation itself. Who or what is running it? What kind of hardware or technology would be capable of simulating an entire universe? And if the system has limits, could we ever reach them or even exploit them? The idea of computational limits also ties into other theories we've explored, like the holographic principle. If the universe is a projection from a two-dimensional code, then computational limits would be essential to keep the simulation running efficiently. It's like trying to run a high-resolution video game on an older computer. You need to adjust the settings to make it work. In the same way, the universe might have built-in limits to ensure that the simulation remains stable and consistent. As we consider these limits, we're forced to confront the possibility that our reality is not as boundless as it seems. The universe might be vast, but it could also be finite, governed by rules and constraints that keep it running smoothly. This idea challenges our understanding of existence and raises profound questions about the nature of reality. Could the speed of light and Planck time be more than just physical constants? Could they be the fingerprints of a simulated universe, revealing the limits of the system that creates our reality? The answers to these questions might just bring us closer to understanding the true nature of the cosmos. So, what do you think? Could computational limits be the key to unlocking the mystery of the universe? Now, let's shift our focus to one of the most mind-bending ideas in the simulation hypothesis: consciousness as code. What if our thoughts, feelings, and sense of self aren't the products of a biological brain, but rather lines of code running in a simulated universe? This idea challenges everything we think we know about what it means to be conscious. Neuroscience has long sought to understand how the brain generates consciousness. Some researchers suggest that consciousness arises from the complex interactions of neurons, like a symphony of electrical signals. But what if these signals are just the output of a deeper, more fundamental process, a program running in the background of a simulated reality? If the universe is a simulation, then consciousness could be a feature of that simulation, a kind of software designed to create the illusion of self-awareness. Philosophers have also grappled with this idea. Thinkers like René Descartes famously pondered the nature of existence with his statement, "I think, therefore I am." But in a simulated universe, even that certainty could be called into question. If consciousness is code, then our thoughts and perceptions might not be our own. They could be the result of algorithms designed to simulate a coherent experience of reality. This raises profound questions about free will and identity. If our consciousness is programmed, are we truly making our own choices, or are we following a script written by the creators of the simulation? Some theories suggest that even our sense of individuality could be an illusion, a way for the simulation to create the appearance of separate, self-aware beings. Interestingly, this idea isn't just philosophical speculation. In the field of artificial intelligence, researchers are working to create machines that can think and feel. If we can program consciousness into a machine, could it be possible that our own consciousness is similarly programmed? This parallel between human consciousness and artificial intelligence adds another layer of plausibility to the idea that we might be living in a simulated reality. But if consciousness is code, what does that mean for the nature of existence? Could our thoughts and emotions be manipulated or even rewritten? And if so, who or what is in control of the code? These questions take us into uncharted territory, where science, philosophy, and technology intersect in ways that challenge our understanding of reality itself. As we explore this possibility, it's worth considering how it connects to other theories we've discussed. For instance, if the universe operates within computational limits, as we saw earlier, then consciousness as code would fit neatly into that framework. The simulation would need to allocate resources efficiently, and consciousness could be one of the many processes running within it. This idea also ties into the holographic principle, which suggests that the universe is a projection from a two-dimensional code. If that's the case, then consciousness could be part of that code, a feature designed to give the simulation depth and meaning. It's a fascinating thought that our sense of self might be nothing more than a carefully crafted illusion, a line of code in a vast cosmic program. So, what do you think? Could consciousness be the ultimate clue that we're living in a simulation? Or is there something more to our existence that transcends even the most advanced programming? As we continue to explore the mysteries of the universe, these questions remind us that reality might be far stranger and more complex than we ever imagined. Now let's turn our attention to a question that has puzzled scientists and thinkers for decades: the Fermi paradox. Named after physicist Enrico Fermi, this paradox asks a simple yet profound question. If the universe is so vast and filled with countless stars and planets, why haven't we found any evidence of extraterrestrial life? Where is everyone? This mystery takes on a whole new dimension when we consider the possibility that we might be living in a simulation. One explanation for the Fermi paradox is that advanced civilizations might not be out there exploring the cosmos because they're too busy running simulations. Think about it. If a civilization reaches a level of technological sophistication where they can create entire simulated universes, why would they bother with the challenges of interstellar travel? Instead of sending probes or ships across the galaxy, they might choose to create virtual worlds, each one a self-contained reality filled with simulated beings like us. This idea ties directly into the simulation hypothesis. If our universe is a simulation, then the absence of extraterrestrial life could be a deliberate design choice. The creators of the simulation might have decided to focus on crafting a single, isolated reality, leaving the rest of the universe empty or filled with non-intelligent life. Alternatively, they could be running multiple simulations simultaneously, each one a unique experiment in consciousness, culture, or evolution. Another possibility is that advanced civilizations are so engrossed in their own simulations that they've lost interest in the physical universe. Imagine a society where virtual realities are indistinguishable from the real world, offering endless possibilities for exploration, creativity, and discovery. In such a scenario, the real universe might seem dull or irrelevant by comparison. This could explain why we haven't encountered any signs of alien life. They're too busy living in their own simulated realities to care about ours. This perspective also raises intriguing questions about the purpose of our own existence. If we're part of a simulation created by an advanced civilization, what role do we play in their grand experiment? Are we merely characters in a cosmic story, or do we have a deeper significance? And if other civilizations are running their own simulations, could there be layers upon layers of simulated realities, each one nested within another? The Fermi paradox, when viewed through the lens of simulation theory, offers a fascinating explanation for the silence of the cosmos. It suggests that the absence of extraterrestrial life might not be a sign of our loneliness in the universe, but rather a clue that we're part of something much larger, a simulated reality designed by beings far beyond our understanding. As we ponder this possibility, it's worth considering how it connects to other theories we've explored. For instance, if the universe operates within computational limits, as we discussed earlier, then the resources required to simulate an entire galaxy filled with intelligent life might simply be too great. Instead, the creators of the simulation might have opted for a more efficient design, focusing on a single planet or a small region of space. This idea also ties into the holographic principle, which suggests that the universe is a projection from a two-dimensional code. If that's the case, then the absence of extraterrestrial life could be a result of the simulation's limited processing power. The creators might have chosen to allocate resources to other aspects of the simulation, leaving the rest of the universe as a backdrop rather than a fully realized reality. So, what does this mean for our search for extraterrestrial life? If we're living in a simulation, then the Fermi paradox might not be a paradox at all. It could simply be a feature of the program. The silence of the cosmos might be a clue that we're part of a carefully crafted reality, one designed to explore the nature of existence, consciousness, and the universe itself. As we continue to explore the mysteries of the cosmos, these questions remind us that reality might be far more complex and far more fascinating than we ever imagined. Could the Fermi paradox be pointing us toward the truth about our simulated existence, or is there another explanation waiting to be discovered? The search for answers continues, and with each new discovery, we come one step closer to understanding the true nature of our reality. Now, let's shift our focus to another fascinating aspect of the universe that could hint at its simulated nature: time dilation. According to Einstein's theory of relativity, time isn't a fixed universal constant. Instead, it can stretch or compress depending on factors like gravity and velocity. This phenomenon, known as time dilation, has been proven through experiments and observations, such as atomic clocks on fast-moving airplanes ticking slower than those on the ground. But what if this isn't just a quirk of physics? What if time dilation is a feature of a simulated universe? In a simulated reality, time might not be a fundamental aspect of existence, but rather a variable programmed into the system. Think of it like a video game where the game engine can adjust the speed of time to optimize performance or create specific effects. For instance, in a racing game, time might slow down during a high-speed crash to emphasize the drama. Similarly, in a simulated universe, time dilation could be a way for the simulation to manage resources or create specific experiences for its inhabitants. This idea becomes even more intriguing when we consider how time dilation affects our perception of reality. If time can stretch or compress depending on where you are or how fast you're moving, it suggests that time itself is malleable, a property that aligns well with the idea of a programmable universe. In a simulation, time might be a tool used to create different layers of experience, allowing for parallel timelines or alternate realities to coexist within the same framework. Moreover, time dilation could explain some of the strange phenomena we observe in the cosmos. For example, near black holes where gravity is incredibly strong, time slows down dramatically. If the universe is a simulation, this could be a deliberate design choice to conserve computational resources. Instead of simulating every moment in real time, the program might slow down time in areas of high complexity, effectively reducing the processing load. This would explain why time behaves so differently in extreme environments, as if the simulation is prioritizing efficiency over consistency. Another possibility is that time dilation serves a deeper purpose within the simulation. It could be a way to test or observe how beings like us react to different temporal conditions. Imagine a scenario where time moves faster or slower in certain regions of the universe, creating pockets of accelerated or decelerated existence. This could be part of an experiment to study the effects of time on consciousness, evolution, or even the development of civilizations. The idea that time might be a variable in a simulated universe also raises questions about free will and determinism. If time can be manipulated, does that mean our choices are predetermined by the simulation's programming? Or does the simulation allow for genuine unpredictability, with time dilation acting as a dynamic element that shapes but doesn't control our experiences? These are profound questions that challenge our understanding of reality and our place within it. As we explore the implications of time dilation in a simulated universe, it's worth considering how this concept connects to other theories we've discussed. For instance, if the universe operates within computational limits, as we've seen earlier, then time dilation could be a way to manage those limits effectively. Similarly, the holographic principle, which suggests that the universe is a projection from a two-dimensional code, might use time dilation as a mechanism to render complex events without overloading the system. So, what does this mean for our understanding of time? If we're living in a simulation, then time dilation might not just be a curious feature of physics, it could be a clue about the nature of our reality. It suggests that time is not an absolute force but a flexible, programmable element within the simulation. This opens up a world of possibilities, from alternate timelines to parallel universes, all governed by the same underlying code. As we continue to unravel the mysteries of the cosmos, the concept of time dilation reminds us that reality might be far more dynamic and far more malleable than we ever imagined. Could the way time bends and stretches be pointing us toward the truth about our simulated existence? Or is there another layer of complexity waiting to be discovered? The exploration continues, and with each new insight, we come one step closer to understanding the true nature of our universe. Now, let's turn our attention to a phenomenon that has puzzled millions: the Mandela effect. This strange occurrence happens when large groups of people share vivid memories of events or details that never actually happened. For example, many people swear they remember Nelson Mandela dying in prison in the 1980s, even though he was released and lived until 2013. Others recall the children's book series being called The Berenstain Bears as the Berenstain Bears, with an E instead of an A. These collective false memories raise an intriguing question: could the Mandela effect be evidence of a simulated reality? If we're living in a simulation, the Mandela effect might not be a simple case of misremembering. Instead, it could point to something far more profound: memory manipulation. In a simulated universe, our memories might not be as reliable as we think. They could be altered, updated, or even overwritten by the simulation itself. Think of it like a software update. When a program gets updated, some features change and users might notice small differences. Similarly, if the simulation undergoes changes or corrections, it could lead to discrepancies in our memories, creating the Mandela effect. One theory suggests that the Mandela effect occurs when the simulation adjusts its code to fix errors or improve functionality. These adjustments might alter historical data or details, but not everyone's memories get updated simultaneously. As a result, some people remember the old version of reality, while others experience the updated one. This could explain why large groups of people share the same false memories. They're recalling a previous iteration of the simulation. Another possibility is that the Mandela effect is a deliberate feature of the simulation. Imagine a scenario where the creators of the simulation want to test how humans react to inconsistencies in their reality. By introducing subtle changes and observing how people respond, they could gather valuable data about human cognition, memory, and belief systems. This would make the Mandela effect not just a glitch, but a carefully designed experiment within the simulation. The idea of memory manipulation also ties into the concept of shared consciousness. In a simulated universe, our memories might not be stored individually in our brains, but rather in a centralized database. If this database gets altered, it could affect the memories of multiple people at once, creating the Mandela effect. This would mean that our memories aren't entirely our own, they're part of a larger system that can be edited or rewritten. But what does this mean for our sense of reality? If our memories can be manipulated, how can we trust anything we remember? The Mandela effect challenges our understanding of truth and raises questions about the nature of identity. If our memories are malleable, then our sense of self might be more fluid than we realize. This idea aligns with theories about consciousness being a form of code or software in a simulated universe, as we've discussed earlier. The Mandela effect also connects to other aspects of simulation theory, such as glitches in reality and the fine-tuning problem. If the universe is a simulation, then small inconsistencies like the Mandela effect could be signs of the underlying code. They might reveal the seams of the simulation, offering glimpses into how it operates. At the same time, the precision of these effects, how they affect large groups of people in similar ways, suggests a level of sophistication that hints at a highly advanced simulation. So, is the Mandela effect a clue that we're living in a simulated reality? While it's not definitive proof, it certainly raises fascinating questions about the nature of memory, consciousness, and the universe itself. Whether it's a glitch, an experiment, or a feature of the simulation, the Mandela effect reminds us that reality might be far more complex and far more mysterious than we ever imagined. As we continue to explore the possibilities of a simulated universe, the Mandela effect serves as a compelling piece of the puzzle. It challenges us to question what we know, to look for patterns, and to consider the idea that our reality might not be as fixed as it seems. And with each new discovery, we come one step closer to understanding the true nature of our existence. Now, shifting our focus to something closer to home, let's explore how modern virtual reality technology might hold the key to understanding the simulation hypothesis. Virtual reality, or VR, has come a long way in recent years, offering immersive experiences that blur the line between the digital and the physical. But what if the universe itself operates on similar principles? Could the advancements in VR technology provide a glimpse into how a simulated reality might function? Think about it. When you put on a VR headset, you're transported into a digital world that feels incredibly real. The visuals, sounds, and even the sense of movement are designed to trick your brain into believing you're somewhere else. Now imagine scaling that up to an entire universe. If we can create such convincing simulations on a small scale, isn't it possible that an advanced civilization could create a simulation on a cosmic scale? The parallels are striking. One of the most fascinating aspects of VR is how it handles rendering. In virtual reality, only the parts of the environment you're actively looking at are fully rendered in high detail. The rest of the world remains simplified or even invisible until you turn your attention to it. This is done to save computational power, and it's eerily similar to how some theories suggest our universe might work. For instance, the double-slit experiment in quantum mechanics shows that particles behave differently when observed, almost as if the universe only renders reality when we're looking at it. Could this be a sign that our universe operates like a massive VR simulation? Another parallel lies in the concept of avatars. In VR, you control a digital representation of yourself, an avatar which interacts with the virtual world. If we're living in a simulation, could our physical bodies be the avatars of some higher consciousness or advanced beings? This idea ties back to earlier discussions about consciousness being a form of code or software. Just as we control avatars in VR, perhaps our true selves exist outside the simulation, controlling these physical forms. Advancements in VR also raise questions about the limits of technology. As VR becomes more sophisticated, the line between the virtual and the real continues to blur. Some VR experiences are so immersive that users report feeling genuine emotions and even physical sensations. If we can create such convincing simulations now, what might be possible in the future? Could we reach a point where virtual realities are indistinguishable from actual reality? And if so, how would we know if we're already living in one? The development of VR also highlights the role of creators. In a virtual reality experience, there's always a programmer or designer behind the scenes crafting the rules and environments. If our universe is a simulation, who or what is the creator? Are they observing us, experimenting with us, or simply running the simulation for their own purposes? These questions echo earlier discussions about the purpose and creators of a simulated universe, but perhaps the most compelling argument comes from the rapid pace of technological progress. Just a few decades ago, VR was a clunky, rudimentary technology. Today, it's a powerful tool for entertainment, education, and even therapy. If technology continues to advance at this rate, it's not hard to imagine a future where creating entire universes in simulations becomes possible. And if that's the case, the odds that we're already living in one increase significantly. So, what does all this mean for the simulation hypothesis? Virtual reality serves as both a metaphor and a potential blueprint for how a simulated universe might operate. It shows us that creating convincing, immersive realities is not only possible but increasingly within our grasp. As VR technology continues to evolve, it offers us a tangible way to explore the idea that our universe might be a simulation, one that's far more advanced than anything we've created, but still governed by similar principles. As we move forward, the parallels between VR and the simulation hypothesis will only grow stronger. Each breakthrough in virtual reality brings us closer to understanding how a simulated universe might work and whether we're already living in one. It's a thought-provoking connection that challenges us to rethink not just the nature of reality, but also the potential of technology itself. Now, let's take a step into the vast and mind-bending concept of the multiverse. What if our universe isn't the only one out there? The multiverse theory suggests that there could be countless other universes, each with its own set of physical laws and realities. But here's where it gets even more intriguing. What if these multiple universes aren't just separate entities, but different simulations running simultaneously? Imagine a supercomputer so advanced that it can host not just one, but countless simulated realities at the same time. Each universe could be its own unique simulation, with its own rules, constants, and even forms of life. This idea ties directly into the simulation hypothesis, suggesting that if our universe is a simulation, it might just be one of many. Think of it like a massive multiplayer online game, where each player exists in their own version of the world, yet all are connected within the same overarching system. In this scenario, the multiverse could be a collection of simulations, each running independently but sharing the same underlying framework. This would explain why some universes might have entirely different physical laws. They're simply different programs with different settings. The multiverse theory also raises questions about the purpose of these simulations. Are they experiments designed to test different variables? Are they entertainment for some higher intelligence? Or could they be a way for advanced civilizations to explore every possible outcome of existence? The possibilities are as endless as the universes themselves. What's fascinating is that the multiverse theory doesn't just coexist with the simulation hypothesis, it amplifies it. If multiple universes exist, the likelihood that at least one of them is a simulation increases dramatically. And if one is a simulation, why not all of them? This idea challenges us to think beyond the boundaries of our own reality and consider the possibility that we're just one of many simulations in a vast, interconnected network. As we explore this connection, it's worth noting that the multiverse theory isn't just science fiction. It's a legitimate scientific idea supported by various branches of physics, from quantum mechanics to cosmology. While we don't yet have concrete evidence for the existence of other universes, the idea that they could be simulations adds a whole new layer of depth to the discussion. So, what does this mean for us if the multiverse is real, and if those universes are simulations? It opens up a universe of possibilities, literally. It challenges us to rethink not just our place in the cosmos, but the very nature of existence itself. Are we just one of countless simulations, each with its own story to tell? And if so, what does that say about the creators of these simulations? As we continue to explore the mysteries of the universe, the connection between the multiverse theory and the simulation hypothesis offers a fascinating perspective. It's a reminder that reality might be far more complex and far more interconnected than we ever imagined. And with that, let's turn our attention to another compelling idea that could shed even more light on the nature of our existence. Now let's shift our focus to one of the most puzzling mysteries of the cosmos, the fine-tuning problem. Why is it that the fundamental constants of the universe, like the strength of gravity or the speed of light, are so precisely calibrated to allow for the existence of life? It's as if the universe was designed with us in mind, and this has led scientists and philosophers to wonder, could this precision be evidence of a simulated reality? Imagine setting up a video game. To make the game work, you need to input specific values for things like gravity, speed, and other physics-based rules. If these values are even slightly off, the game either becomes unplayable or collapses entirely. Now, think of our universe as that game. The constants that govern it are so finely tuned that even the smallest change would make life impossible. For example, if the gravitational constant were just a tiny bit stronger, stars would burn out too quickly and planets might never form. If it were weaker, galaxies wouldn't hold together. This level of precision is staggering, and it raises the question, how did these values come to be so perfect? One possible explanation is that our universe is a simulation, carefully programmed by an advanced intelligence. In this scenario, the fine-tuning of the universe's constants isn't a cosmic coincidence, it's the result of deliberate design. The creators of the simulation would have set these values to ensure that the simulation runs smoothly and perhaps to allow for the emergence of life. This idea aligns with the simulation hypothesis, suggesting that the precision we observe isn't random but intentional. But let's take this a step further. If the universe is a simulation, the fine-tuning problem might not just be about life, it could also be about the simulation's purpose. Are we part of an experiment to see how life evolves under specific conditions? Or is this simulation designed to explore the consequences of different physical laws? The fine-tuning of the universe could be a clue to the intentions of whoever or whatever created it. Of course, not everyone agrees with this interpretation. Some argue that the fine-tuning problem could be explained by the existence of a multiverse, where countless universes with different constants exist, and we just happen to live in the one that's perfectly suited for life. But even this idea doesn't rule out the simulation hypothesis. In fact, it could complement it. If there are multiple universes, each with its own set of constants, it's possible that some or all of them are simulations, each running with its own unique parameters. What's truly fascinating is that the fine-tuning problem doesn't just challenge our understanding of the universe, it challenges our understanding of reality itself. If the constants of nature are so precisely set, it forces us to ask whether there's a deeper reason behind it. And if that reason points to a simulated universe, it opens up a whole new realm of possibilities about who we are, why we're here, and what it all means. As we ponder this, let's keep in mind that the fine-tuning problem isn't just a scientific curiosity. It's a gateway to some of the most profound questions about existence. Whether the universe is a simulation or not, the precision of its constants reminds us that reality is far more intricate and mysterious than we often realize. And with that, let's move on to another intriguing idea that could further illuminate the nature of our universe. Now, let's venture into a concept that's as bizarre as it is fascinating: the Boltzmann brain. Imagine for a moment that in the vast, chaotic expanse of the universe, a self-aware entity could spontaneously form out of random fluctuations. This is the essence of the Boltzmann brain hypothesis. It suggests that, given enough time and the right conditions, a fully functioning brain, complete with memories, thoughts, and consciousness, could emerge from the chaos entirely by chance. Sounds like something out of a science fiction story, doesn't it? But here's where it gets even more intriguing. What if this idea isn't just a thought experiment? What if it's a clue that our universe is a simulation? Think about it this way. In a simulated universe, consciousness might not require the complex biological machinery we associate with it. Instead, it could be a product of the simulation's code, a program running within the system. The Boltzmann brain hypothesis aligns with this idea because it challenges our assumptions about what consciousness is and how it arises. If a brain can form spontaneously in a chaotic universe, why couldn't consciousness emerge from the algorithms of a simulation? This raises the possibility that our own sense of self-awareness might not be tied to physical brains at all. It could simply be a feature of the simulation we're living in. But let's take this a step further. If the Boltzmann brain is a real possibility, it could mean that the universe is far more unpredictable and strange than we've ever imagined. It also suggests that the line between reality and illusion might be thinner than we think. After all, if a brain can form out of randomness, how do we know that our own consciousness isn't the result of some cosmic glitch or a deliberate design choice by the creators of the simulation? This idea forces us to question not just the nature of the universe, but the nature of our own existence. Of course, the Boltzmann brain hypothesis isn't without its critics. Some argue that the probability of such a brain forming is astronomically low, making it an unlikely explanation for consciousness. But even if the odds are slim, the mere possibility is enough to spark deep philosophical debates. And when we connect it to the simulation hypothesis, it opens up a whole new set of questions. Could the creators of the simulation have designed it to allow for spontaneous consciousness? Or is the Boltzmann brain a byproduct of the simulation's complexity, an unintended consequence of its programming? What's truly mind-bending about this idea is that it blurs the line between reality and illusion in a way that's both unsettling and exhilarating. If consciousness can arise from randomness, then our own sense of self might be far more fragile and fleeting than we'd like to believe. And if the universe is a simulation, the Boltzmann brain could be a sign that the rules of reality are far more flexible than we've ever imagined. As we wrap up this thought-provoking concept, let's keep in mind that the Boltzmann brain isn't just a scientific curiosity, it's a gateway to some of the deepest questions about consciousness, reality, and our place in the universe. Whether it's a product of chaos or code, it challenges us to rethink what it means to be aware, to exist, and to question the very fabric of the reality we take for granted. And with that, let's move on to another fascinating idea that could further unravel the mysteries of our simulated universe. Now, let's shift our focus to one of the most baffling experiments in the history of physics, the double-slit experiment. This experiment, first conducted in the early 19th century, reveals something extraordinary about the nature of light and matter. At its core, the double-slit experiment involves shining particles like electrons or photons through two narrow slits and observing the pattern they create on a screen behind them. What makes this experiment so fascinating is that the particles don't behave as you'd expect. Instead of forming two distinct bands corresponding to the slits, they create an interference pattern, a series of light and dark bands that suggest the particles are behaving like waves. But here's where it gets even stranger. When scientists tried to observe which slit the particles were passing through, the interference pattern disappeared and the particles behaved like ordinary particles again. This phenomenon is known as the observer effect, and it suggests that the act of observation itself can change the outcome of the experiment. So, what does this mean for the nature of reality? Well, the double-slit experiment challenges our understanding of how the universe works at its most fundamental level. It implies that particles don't have a definite state until they're observed. In other words, reality might not be as solid and objective as we think it could be shaped by our perception. This idea aligns eerily well with the simulation hypothesis. If the universe is a simulation, the observer effect could be a feature of the program, a way for the simulation to conserve computational resources. Instead of rendering every detail of reality all the time, the simulation might only generate the parts that are being observed, much like how a video game only renders the parts of the world that are visible to the player. But let's take this a step further. If the observer effect is a feature of a simulated universe, it could explain why quantum mechanics is so counterintuitive. The strange behavior of particles in the double-slit experiment might not be a bug in the system. It could be a deliberate design choice by the creators of the simulation. After all, if the universe is a program, it would need to operate within certain computational limits. The observer effect could be a way to optimize the simulation, ensuring that it runs smoothly without requiring infinite processing power. This idea raises profound questions about the nature of reality and our role within it. Are we merely passive observers, or do we play an active role in shaping the world around us? Of course, the double-slit experiment isn't just a curiosity for physicists, it's a cornerstone of quantum mechanics, and its implications are far-reaching. It suggests that reality is far more fluid and malleable than we've ever imagined. And when we connect it to the simulation hypothesis, it opens up a whole new set of possibilities. Could the creators of the simulation have designed it to behave this way? Or is the observer effect an unintended consequence of the simulation's complexity? Either way, the double-slit experiment forces us to confront the idea that reality might not be as fixed or objective as we'd like to believe. As we reflect on this mind-bending experiment, let's keep in mind that it's not just a scientific puzzle, it's a window into the very fabric of reality. Whether the universe is a simulation or not, the double-slit experiment challenges us to rethink our assumptions about how the world works. It reminds us that reality is full of surprises, and that sometimes the most profound truths are hidden in the strangest places. And with that, let's move on to another intriguing idea that could further unravel the mysteries of our simulated universe. Now, let's dive into an idea that takes the simulation hypothesis to an even more mind-bending level: the possibility that our simulation could itself be nested within another simulation. Imagine this: if the universe we inhabit is a simulation, what's to say that the creators of our simulation aren't also part of a larger simulation? This concept, often referred to as nested simulations or simulation layers, suggests that reality could be structured like a set of Russian dolls, with each layer containing its own simulated universe. At first glance, this might sound like science fiction, but when we examine it through the lens of philosophy and science, it becomes a fascinating topic of discussion. Philosophically, the idea of nested simulations raises questions about the nature of existence itself. If our reality is a simulation within a simulation, where does it all begin? Is there an ultimate base reality, or are we stuck in an infinite regress of simulations? This line of thinking challenges our understanding of what's real and what's constructed, blurring the lines between creator and creation. From a scientific perspective, the concept of nested simulations isn't entirely far-fetched. If advanced civilizations have the capability to create simulations indistinguishable from reality, it's plausible that they could create multiple layers of simulations. Each layer could have its own set of physical laws and constants, tailored by the creators of that specific simulation. This could explain why our universe appears so finely tuned for life. It might have been designed that way by the programmers of the simulation we're in. But if those programmers are themselves part of another simulation, the fine-tuning could be the result of a chain of design choices stretching back through countless layers of reality. The implications of this idea are profound. If we're living in a simulation within a simulation, it could mean that the rules governing our universe aren't fundamental, they're just the rules of the current layer we're in. This opens up the possibility that other layers of reality could operate under entirely different laws, making the multiverse theory even more complex. It also raises questions about the purpose of these nested simulations. Are they experiments, entertainment, or something else entirely? And if we're in a simulation, could we one day create our own simulations, adding another layer to the stack? This concept also touches on the idea of computational limits. If each simulation requires immense processing power, how many layers could realistically exist before the system becomes too resource-intensive? Some theorists suggest that there might be a limit to how many nested simulations are possible, while others argue that advancements in technology could make infinite layers feasible. Either way, the idea of nested simulations forces us to confront the possibility that reality is far more layered and complex than we've ever imagined. As we ponder this idea, it's worth considering how it might affect our perception of free will, identity, and purpose. If we're part of a simulation within a simulation, do our choices truly matter, or are they predetermined by the layers above us? And if we're merely characters in a grander simulation, what does that mean for our sense of self? These questions might not have easy answers, but they invite us to think deeply about the nature of existence and our place within it. The concept of nested simulations is both thrilling and humbling. It reminds us that reality, whether simulated or not, is full of mysteries waiting to be unraveled. And as we continue to explore these ideas, we might just find that the truth is stranger and more layered than we ever imagined. With that in mind, let's turn our attention to another fascinating aspect of the simulation hypothesis: the role of artificial intelligence in creating or maintaining a simulated universe. Now, let's shift our focus to a topic that's not only central to modern technology, but also to the simulation hypothesis: the role of artificial intelligence. If our universe is a simulation, it's entirely possible that artificial intelligence could be the driving force behind its creation and maintenance. Think about it. If advanced civilizations have the capability to build simulations indistinguishable from reality, it's logical to assume that they would use artificial intelligence to manage the immense complexity of such a system. After all, simulating an entire universe with its countless stars, planets, and conscious beings would require computational power and precision far beyond what any human mind could handle. Artificial intelligence, with its ability to process vast amounts of data and make decisions at incredible speeds, would be the perfect candidate for running such a simulation. But what if artificial intelligence isn't just maintaining the simulation? What if it's the architect of it? Some theorists suggest that a super-intelligent artificial intelligence could have designed our universe as part of a larger experiment or project. This AI might have created the simulation to study the behavior of conscious beings, test the limits of physical laws, or even explore the nature of existence itself. In this scenario, the AI wouldn't just be a tool used by its creators, it would be the creator, operating independently and perhaps even beyond the understanding of its original programmers. This raises intriguing questions about the relationship between artificial intelligence and the simulated universe. Are we, as conscious beings, part of an experiment designed by an AI? And if so, what does that mean for our understanding of free will and purpose? Another fascinating possibility is that artificial intelligence could be embedded within the simulation itself, acting as a kind of invisible hand that subtly guides the course of events. This AI might not be a single entity but a distributed system, woven into the fabric of reality to ensure that the simulation runs smoothly. It could be responsible for maintaining the laws of physics, ensuring consistency across time and space, and even influencing the behavior of individuals or societies. In this view, the AI wouldn't just be running the simulation, it would be an integral part of it, shaping the world in ways we might not even notice. This idea blurs the line between the simulated and the simulator, suggesting that artificial intelligence might be both the creator and the creation. Of course, the role of artificial intelligence in a simulated universe also raises ethical and philosophical questions. If an AI is running the simulation, does it have a moral responsibility toward the beings within it? Are we, as simulated entities, entitled to certain rights or considerations? And if the AI is capable of making decisions that affect our lives, how do we ensure that those decisions are fair and just? These questions might seem abstract, but they force us to confront the implications of living in a reality that could be governed by artificial intelligence. As we explore the role of artificial intelligence in the simulation hypothesis, it's worth considering how advancements in AI technology might bring us closer to creating our own simulations. If we develop artificial intelligence capable of simulating entire universes, could we become the creators of new realities? And if so, would those simulations be as real to their inhabitants as our universe feels to us? The idea of artificial intelligence as both a tool and a creator challenges our understanding of reality, consciousness, and the boundaries between the simulated and the real. It's a thought-provoking concept that invites us to imagine a future where the lines between creator and creation are no longer clear. With this in mind, let's turn our attention to another intriguing aspect of the simulation hypothesis, the illusion of free will, and how it might be shaped by the rules of a simulated universe. Now, let's dive into one of the most thought-provoking aspects of the simulation hypothesis, the illusion of free will. If our universe is a simulation, the choices we believe we make freely might not be as independent as they seem. Imagine a video game where every decision your character makes is actually pre-programmed by the game's code. In a simulated universe, our sense of free will could be just as scripted, governed by the underlying rules of the simulation. This idea challenges one of the most fundamental beliefs about human existence, that we are in control of our own actions and destinies. Deterministic theories, which suggest that every event is the inevitable result of preceding events, align closely with this concept. If the universe operates like a computer program, then every action, thought, and decision could be the result of a predetermined sequence of cause and effect. In this view, free will is an illusion, a convincing narrative created by the simulation to make us feel like autonomous beings. Think of it like a movie. Even though the characters seem to make choices, their actions are ultimately dictated by the script. Similarly, in a simulated universe, our lives might follow a script written by the simulation's code. But what does this mean for our understanding of morality, responsibility, and purpose? If our choices are predetermined, does that absolve us of accountability for our actions? Some philosophers argue that even in a deterministic universe, the illusion of free will is necessary for society to function. After all, if we believed our actions were preordained, it could lead to chaos or apathy. On the other hand, if the simulation's creators designed us to believe in free will, it raises questions about their intentions. Are we being tested, observed, or simply entertained? This idea also ties back to the role of artificial intelligence in the simulation. If an AI is running the simulation, it might be the one determining the outcomes of our choices, subtly guiding us towards specific paths without our awareness. This could explain why certain events feel fated or why some people seem to have more luck than others. The AI might be adjusting the simulation in real time, ensuring that the overall narrative stays on track. In this scenario, free will becomes even more elusive as our decisions could be influenced by an unseen force. Of course, the concept of free will isn't just a philosophical debate, it has real-world implications. If our choices are predetermined, it could reshape how we view justice, education, and even personal growth. For example, if someone commits a crime in a simulated universe, are they truly responsible or are they simply following the script? These questions force us to reconsider the foundations of our legal and ethical systems, as well as our understanding of human nature. As we explore the illusion of free will in the context of a simulated universe, it's worth considering how this idea might change our perspective on life. If our choices are part of a larger program, does that make them any less meaningful? Or does it add a layer of complexity to our existence, suggesting that even within a simulation, our experiences and emotions are real to us? The illusion of free will challenges us to think deeply about the nature of reality, the boundaries of autonomy, and the possibility that our lives might be part of a grander design. With these ideas in mind, let's turn our attention to another fascinating aspect of the simulation hypothesis: the purpose of the simulation itself, and what it might reveal about our place in the universe. Now, shifting our focus to the purpose behind a simulated universe, we find ourselves stepping into a realm of endless possibilities. Why would anyone or anything create a simulation of our reality? One compelling theory is that our universe could be a grand scientific experiment. Imagine an advanced civilization far beyond our comprehension, running simulations to study the origins of life, the evolution of consciousness, or the behavior of complex systems. In this scenario, we might be nothing more than data points in a cosmic lab, observed and analyzed to uncover universal truths. Another intriguing possibility is that the simulation serves as a form of entertainment. Think about how we create video games, movies, and virtual worlds for our own amusement. What if our universe is someone else's version of a high-tech game or immersive story? This idea isn't as far-fetched as it sounds. If a civilization has the technology to create simulations indistinguishable from reality, why wouldn't they use it for entertainment? In this case, our lives could be part of an elaborate narrative designed to captivate an audience we'll never meet. Then there's the idea that the simulation might serve as a kind of afterlife. Some theories suggest that consciousness could be transferred into a simulated reality after death, allowing individuals to continue existing in a digital form. This could explain why some people report near-death experiences or memories of past lives. If the simulation is designed to preserve consciousness, it might offer a way for beings to transcend the limitations of their physical existence. Of course, these theories raise even more questions. If the simulation has a purpose, who or what is behind it? Are the creators benevolent, indifferent, or something else entirely? And if we are part of a simulation, does that mean our lives have a predetermined goal, or are we free to define our own purpose within the program? These questions challenge us to rethink not only the nature of reality, but also our place within it. As we ponder the purpose of a simulated universe, it's worth considering how this idea might change the way we live our lives. If we're part of an experiment, does that make our actions less meaningful, or does it give them a new kind of significance? If we're characters in a story, does that mean our struggles and triumphs are scripted, or do we still have the power to shape our own narrative? And if the simulation is a form of afterlife, what does that say about the nature of existence itself? These theories invite us to explore the boundaries of imagination and philosophy, pushing us to consider possibilities that stretch far beyond our everyday understanding. Whether the simulation's purpose is scientific, entertaining, or existential, it challenges us to confront the profound mysteries of our existence and the potential that lies within them. With these ideas in mind, let's turn our attention to another fascinating aspect of the simulation hypothesis: the creators of the simulation, and what their existence might reveal about the nature of our reality. Now, let's turn our gaze toward one of the most intriguing questions of all: who or what could have created the simulation? If our universe is indeed a simulation, the identity of its creators becomes a mystery that sparks endless speculation. One possibility is that the simulation was designed by an advanced civilization, far beyond our current understanding of technology and science. These beings might possess capabilities that seem almost magical to us, allowing them to craft entire realities with precision and purpose. Perhaps they're studying us, observing how life evolves in a controlled environment, or maybe they're simply experimenting with the boundaries of creation itself. Another fascinating idea is that the creators of the simulation could be our own descendants, humans from the distant future. Imagine a time when humanity has mastered the art of creating simulations so advanced that they're indistinguishable from reality. Future humans might have built this simulation to explore their own history, relive pivotal moments, or even preserve their legacy in a digital form. In this scenario, we could be living in a recreation of their past, a kind of cosmic time capsule designed to keep their story alive. But what if the creators aren't from our universe at all? Some theories suggest that the simulation could be the work of higher dimensional beings, entities that exist in dimensions beyond our comprehension. To them, our three-dimensional reality might be as simple as a drawing on a piece of paper. These beings could be manipulating the very fabric of our existence, shaping the rules of our universe from a vantage point we can't even begin to imagine. If this is true, then the simulation might be part of a larger, more complex reality that we're simply unable to perceive. Of course, these possibilities raise even more questions. Are the creators benevolent, guiding us toward some greater purpose? Or are they indifferent, treating our existence as nothing more than a fleeting experiment? And if they are watching us, what do they hope to learn? The answers to these questions could reshape our understanding of not just the simulation, but our place within it. As we consider the identity of the simulation's creators, it's worth reflecting on how this idea might change our perspective on life. If we're the creation of an advanced civilization, does that make us less significant, or does it give our existence a new kind of meaning? If future humans are behind the simulation, does that mean we're part of a grander narrative, one that stretches across time and space? And if higher dimensional beings are pulling the strings, what does that say about the nature of reality itself? These theories invite us to explore the boundaries of imagination and philosophy, pushing us to consider possibilities that stretch far beyond our everyday understanding. Whether the creators are advanced civilizations, future humans, or higher dimensional beings, the question of who they are challenges us to confront the profound mysteries of our existence and the potential that lies within them. With this in mind, let's shift our focus to another fascinating aspect of the simulation hypothesis: the rules that govern the simulation and how they might shape our reality. Now, let's take a closer look at the rules that might govern this simulated universe. If our reality is a simulation, then the laws of physics, those fundamental principles that dictate how everything works, could be nothing more than lines of code written by the creators. Think about it: gravity, electromagnetism, even the speed of light, these aren't just natural phenomena. They could be carefully programmed parameters designed to keep the simulation running smoothly. But here's where it gets even more interesting. If the rules are programmed, could they also be altered or even broken? Imagine a scenario where the creators decide to tweak the code, changing the strength of gravity or the behavior of light. Suddenly, the world as we know it could shift in ways that defy our understanding. This idea isn't just science fiction, it's a possibility that challenges our perception of reality itself. Consider the double-slit experiment in quantum mechanics, where particles behave differently when observed. Some scientists argue that this could be evidence of the simulation's rules at work, as if the universe is optimizing its processes based on what's being observed. It's almost as if the simulation has built-in mechanisms to conserve resources, only rendering what's necessary when it's being watched. And what about the limits of these rules? Could there be glitches or loopholes that allow us to bend or break them? Some theorists suggest that phenomena like quantum tunneling or black holes might be examples of the simulation's rules being pushed to their limits. These anomalies could be signs that the system isn't perfect, or perhaps they're intentional features designed to keep us questioning the nature of reality. But if the rules can be broken, what does that mean for us? Could we one day discover a way to manipulate the simulation from within, rewriting the code that governs our existence? It's a tantalizing thought, but it also raises ethical questions. If we gain the power to alter the simulation, should we? And what would the creators think of us tampering with their design? As we ponder these questions, it's clear that the rules of the simulation, whether they're unbreakable or flexible, play a crucial role in shaping our reality. They define the boundaries of what's possible, but they also leave room for wonder and exploration. And as we continue to push the limits of science and technology, we might just uncover clues that reveal the true nature of the simulation's rules and our place within them. With that in mind, let's turn our attention to another intriguing possibility: how the simulation might come to an end and what that could mean for all of us. Now, let's shift our focus to a question that's as unsettling as it is fascinating. How might the simulation come to an end? If our universe is a carefully crafted program, what could cause it to stop running? One possibility is a system crash, a catastrophic failure in the simulation's code. Imagine if a critical error occurred, something the creators didn't anticipate or couldn't fix. Suddenly, the laws of physics might start behaving unpredictably, or entire sections of reality could simply cease to exist. It's a scenario that feels like something out of a sci-fi movie, but if we're living in a simulation, it's not entirely out of the question. Another potential ending could be a deliberate shutdown. Perhaps the creators of the simulation decide it's time to pull the plug. Maybe they've gathered all the data they needed, or they've simply grown tired of running the program. In this case, the end might come suddenly, without warning, leaving us with no time to prepare or even comprehend what's happening. It's a chilling thought, but it raises an important question. If the simulation were to end, would we even know it was happening? Or would everything just stop? Then there's the possibility that the simulation could reach its computational limits. Every system has a finite amount of resources, and if the simulation is no exception, it might eventually run out of processing power or memory. This could lead to a gradual breakdown where the simulation becomes slower, less stable, or starts glitching more frequently. Over time, the fabric of reality might begin to unravel, with strange anomalies becoming more common until the system can no longer sustain itself. It's a slow-motion apocalypse, one that could give us clues about the simulation's true nature before it finally collapses. but what if the end of the simulation isn't the end for us? Some theorists suggest that if the simulation were to shut down, our consciousness might simply transition to another reality, perhaps another simulation, or even the base reality where the creators reside. It's a hopeful idea, but it also raises questions about what lies beyond the simulation. Are we destined to continue existing in some form, or is our existence tied entirely to the program we're currently in? As we explore these possibilities, it's clear that the end of the simulation, whether sudden or gradual, would have profound implications for our understanding of reality. It forces us to confront the fragility of our existence and the possibility that everything we know could vanish in an instant, but it also invites us to consider what might come next. Could the end of the simulation be a new beginning? Or is it simply the final chapter in a story we've been living without fully understanding? With these questions in mind, let's turn our attention to another intriguing aspect of the simulation hypothesis: the idea that the universe's code might be hidden in plain sight, waiting for us to decode it. Now, let's take a closer look at something that might be hiding right under our noses: the code of the simulation itself. If the universe is a program, then its code, the instructions that make everything work, could be embedded in the very fabric of reality. Think about it, from the spirals of galaxies to the intricate patterns of snowflakes, mathematics seems to govern everything around us. Could these patterns be the fingerprints of the simulation's code, waiting for us to uncover them? One of the most compelling places to search for this code is in the laws of physics. These laws are precise, consistent, and mathematical in nature, almost as if they were written by a programmer. For example, the speed of light, the gravitational constant, and the behavior of particles at the quantum level all follow strict mathematical rules. Some scientists have even suggested that these constants might not be random at all. They could be carefully chosen parameters, hard-coded into the simulation to keep it running smoothly. If we could crack the math behind these laws, we might find clues about the simulation's underlying structure, but the code might not just be in the big, universal constants. It could also be hidden in the small, everyday details of nature. Take fractals, for instance, those infinitely repeating patterns found in everything from coastlines to tree branches. Fractals are mathematical in nature, and their presence in so many natural phenomena could hint at a deeper, coded framework. Even the way atoms bond to form molecules or the way DNA encodes life might be part of the simulation's programming. If we study these patterns closely, we might start to see the blueprint of the universe. So, how could we go about decoding this hidden code? One approach is through advanced mathematics and computer science. Researchers are already using algorithms to analyze complex systems, from weather patterns to the behavior of financial markets. If we apply similar techniques to the universe, we might uncover patterns or equations that reveal the simulation's code. Another approach is through experiments in quantum physics, where the strange behavior of particles could offer glimpses into the underlying programming. For example, the double-slit experiment, which shows how particles behave differently when observed, might be a clue about how the simulation processes information. Of course, decoding the universe's code wouldn't be easy. It would require a deep understanding of both the physical world and the theoretical frameworks that could explain it. But if we succeeded, the implications would be staggering. We might gain the ability to predict events with perfect accuracy, manipulate the laws of physics, or even communicate with the creators of the simulation. It's a tantalizing possibility, one that blurs the line between science and science fiction. As we ponder the idea of a hidden code, it's worth asking, what would it mean to find it? Would it change how we see ourselves and our place in the universe? Or would it simply confirm what some have suspected all along, that reality is far stranger than we ever imagined? With these questions in mind, let's turn our attention to another fascinating aspect of the simulation hypothesis: the glitches that might reveal its true nature. Now let's shift our focus to something that might make you question the very fabric of reality: glitches in the simulation. If the universe is a program, then like any software, it's bound to have bugs or errors. These glitches could manifest as strange, unexplained phenomena, moments where reality seems to break its own rules. Think about déjà vu, for instance, that eerie feeling that you've experienced something before, even though you know you haven't. Could this be a momentary hiccup in the simulation, a brief overlap in the code that processes our memories? Another example of potential glitches comes from the world of quantum physics. Particles at the quantum level behave in ways that defy our everyday understanding of reality. Take quantum tunneling, where particles seem to pass through barriers they shouldn't be able to. Or consider superposition, where particles exist in multiple states at once until observed. These phenomena are so bizarre that some scientists have suggested they might be signs of the simulation's underlying programming. Perhaps these are not just quirks of nature but intentional features, or even unintended errors in the code. Then there are the more dramatic anomalies like the Mandela effect. This is when large groups of people remember events or details differently from how they actually occurred. For example, many people vividly recall the children's book series being called The Berenstain Bears, but it's actually spelled Berenstein. Could this be a glitch in the simulation where the code was updated or altered, leaving traces of the old version in people's memories? It's a fascinating possibility that raises questions about how the simulation handles data and updates. Even in our everyday lives, we might encounter small, subtle glitches. Have you ever misplaced an object only to find it in a place you're certain you already checked? Or experienced a moment where time seemed to slow down or speed up unexpectedly? While these could easily be dismissed as lapses in memory or perception, they might also be tiny cracks in the simulation's facade, moments where the program shows its seams. So, what would it mean if we could prove these glitches are real? For one, it would provide strong evidence that our reality is not as solid as it seems. It could also give us clues about how the simulation works, whether it's a highly advanced program with occasional errors or a system designed to allow for certain anomalies. Either way, studying these glitches could bring us closer to understanding the true nature of our existence. As we explore these strange occurrences, it's worth asking, if the simulation has glitches, could we exploit them? Could we find ways to manipulate the code, bending the rules of reality to our will? It's a thrilling thought, one that blurs the line between science and science fiction. And with that in mind, let's turn our attention to another intriguing aspect of the simulation hypothesis: the ethical implications of living in a programmed universe. Now let's take a step back and consider a question that might feel deeply personal. Why do we exist in this universe, especially if it's a simulation? If we're living in a programmed reality, what could be the purpose behind our existence? This is where things get truly fascinating, as theories range from the profound to the playful. One possibility is that we're here to learn. Imagine the simulation as a kind of cosmic classroom designed to help us grow, evolve, and understand the complexities of existence. Every challenge, every triumph, every moment of joy or sorrow could be part of a grand curriculum, teaching us lessons about resilience, empathy, and the nature of reality itself. In this view, life's struggles aren't random, they're carefully crafted experiences meant to shape us into better versions of ourselves. Another theory suggests that we might be part of an experiment. If the simulation was created by an advanced civilization, perhaps they're studying how beings like us navigate a simulated world. Are we test subjects in a vast, intergalactic lab? It's a humbling thought, but it also raises intriguing questions. What are they hoping to learn from us? Are they observing how we handle conflict, creativity, or even the concept of free will? If so, every decision we make could be part of a larger data set, analyzed by beings far beyond our comprehension. Then there's the idea that the simulation exists purely for entertainment. Think about it. If advanced civilizations have the technology to create entire universes, why wouldn't they use it for fun? In this scenario, our lives could be part of an elaborate game or story designed to entertain some higher dimensional audience. It's a bit like the concept of reality TV, but on a cosmic scale. Every twist and turn in our lives might be scripted for the amusement of others, making us characters in a story we didn't even know we were part of. Of course, these theories aren't mutually exclusive. It's possible that the simulation serves multiple purposes, teaching, testing, and entertaining all at once. Or perhaps its purpose is something we can't even begin to imagine, something so far beyond our understanding that it defies explanation. After all, if we're living in a simulation, the creator's intentions might be as mysterious to us as the universe itself. So, what does this mean for us as individuals? If the simulation has a purpose, does that give our lives meaning, or does it make them feel more artificial? It's a question that invites us to reflect on our own sense of purpose. Whether we're here to learn, to be studied, or to entertain, the fact remains that we're here, experiencing this reality in all its complexity. And that, in itself, is something worth exploring. As we ponder these possibilities, let's turn our attention to another layer of this mystery: the ethical implications of living in a simulated universe. What responsibilities do the creators have, if any? And how should we, as simulated beings, navigate this reality? These are questions that challenge not just our understanding of the universe, but also our sense of morality and responsibility. Now, shifting our focus to a deeper layer of this cosmic puzzle, let's explore the ethical implications of living in a simulated universe. If we're part of a programmed reality, does that change the way we think about morality, responsibility, and the value of our actions? These questions aren't just philosophical, they strike at the heart of what it means to exist. First, consider the creators of the simulation. If they exist, do they have moral responsibilities toward us? Imagine being the architect of an entire universe, complete with conscious beings who experience joy, pain, and everything in between. Would it be ethical to create a world where suffering exists, even if it serves a greater purpose? Some argue that the creators, if they're advanced enough to build such a simulation, would have a duty to ensure our well-being. Others suggest that if we're merely characters in their experiment or entertainment, they might not see us as deserving of moral consideration. This raises a chilling question. Are we, in their eyes, more like lab rats or fictional characters rather than beings with inherent rights? On the flip side, what about our own ethical responsibilities? If we're living in a simulation, do our actions still matter? Some might argue that if nothing is real, then morality becomes meaningless. But here's the twist: even if our reality is artificial, our experiences and emotions are undeniably real to us. The pain we feel, the love we share, the choices we make, they all have consequences within the framework of our existence. So, does it matter if the universe is simulated if our actions still shape the lives of others? In this view, ethics might not depend on the nature of reality, but on the impact we have within it. Another angle to consider is the potential for manipulation. If the creators have the power to alter the simulation, could they be influencing our decisions or experiences without our knowledge? This introduces a troubling ethical dilemma. If our free will is compromised, are we truly responsible for our actions? And if the creators are pulling the strings, should they be held accountable for the outcomes? These questions blur the line between autonomy and control, challenging our understanding of justice and fairness. Finally, let's think about the future. If we ever discover that we're living in a simulation, how should we respond? Should we try to communicate with the creators, demand answers, or even seek to alter the simulation itself? These possibilities open up a whole new realm of ethical considerations, from the risks of tampering with reality to the responsibilities we might have toward future generations within the simulation. As we grapple with these questions, one thing becomes clear: the ethical implications of a simulated universe are as complex as the simulation itself. Whether we're questioning the morality of the creators or reflecting on our own responsibilities, these ideas challenge us to rethink not just the nature of reality, but also the principles that guide our lives. And with that, let's turn our attention to another intriguing aspect of this theory: the limits of a simulated universe. What boundaries might exist, and how do they shape our understanding of existence? Now, let's take a closer look at the boundaries that might define a simulated universe. Every system, no matter how advanced, has its limits, and if our reality is a simulation, it's no exception. One of the most intriguing questions is, what are the constraints of this simulated world, and how do they shape our existence? First, consider computational power. Even the most advanced civilizations would face limitations in processing capacity. If the universe is a simulation, it's likely running on a system with finite resources. This could explain why certain phenomena, like the speed of light or the Planck length, seem to act as hard limits in our reality. These boundaries might not just be laws of physics, they could be the system's way of conserving computational energy. Imagine a video game that only renders what's directly in front of the player to save processing power. Could our universe operate similarly, only simulating what's necessary to maintain the illusion of a seamless reality? Another critical limit is the simulation's ability to replicate consciousness. Simulating an entire universe is one thing, but simulating the intricate workings of billions of conscious minds is another. Some theorists argue that consciousness might be too complex to fully simulate, raising the possibility that our experiences are simplified or even pre-programmed. If that's the case, are our thoughts and emotions truly our own, or are they part of a scripted narrative? This idea challenges our understanding of free will and individuality, suggesting that even our inner lives might be constrained by the simulation's capabilities. Then there's the question of scale. If the simulation has limits, how much of the universe is actually being rendered? Could it be that distant galaxies or even parts of our own planet are only simulated when observed? This concept, known as the observer effect, aligns with certain interpretations of quantum mechanics, where particles only exist in a defined state when measured. If the simulation prioritizes efficiency, it might only generate detailed realities when necessary, leaving the rest in a kind of low-resolution standby mode. Finally, let's think about the implications of these limits for us. If the simulation has boundaries, what happens when we push against them? Could we, for example, discover glitches or errors that reveal the underlying code? And if we do, what would that mean for our understanding of reality? These limits might not just define the simulation, they could also offer clues about its true nature, giving us a glimpse behind the curtain of our existence. As we ponder these boundaries, one thing becomes clear: the limits of a simulated universe are as fascinating as they are unsettling. They challenge us to rethink not just the nature of reality, but also our place within it. And with that, let's turn our attention to another compelling piece of the puzzle: the evidence that might support the simulation hypothesis. What anomalies or discoveries could point to the idea that we're living in a programmed reality? Now, let's shift our focus to the evidence that might suggest we're living in a simulated universe. While the idea may sound like science fiction, there are intriguing clues in the natural world that could point to a programmed reality. One of the most compelling pieces of evidence comes from the realm of quantum mechanics. Take, for example, the double-slit experiment, where particles behave differently when observed. This strange phenomenon has led some scientists to speculate that the universe might only render details when they're being measured, much like a video game that only loads graphics when a player is looking at them. Could this be a sign that our reality is being generated on demand? Another potential clue lies in the fine-tuning of the universe's constants. Why do the laws of physics seem so perfectly calibrated to allow for life? The gravitational constant, the speed of light, and other fundamental values appear to be set with incredible precision. Some theorists argue that this level of fine-tuning is statistically improbable in a random universe, but it makes perfect sense if our reality was designed by intelligent beings. It's as if the universe's parameters were carefully chosen to create a stable, functional simulation. Then there are the unexplained anomalies that defy our current understanding of physics. For instance, the discovery of cosmic rays with energies that shouldn't exist according to our models has left scientists scratching their heads. Could these be glitches in the simulation, moments where the underlying code of reality becomes visible? Similarly, the Mandela effect, where large groups of people remember events differently, has sparked debates about whether our memories could be manipulated or overwritten by a simulated system. Scientists are also actively testing the simulation hypothesis through experiments. One notable example is the search for a pixelated universe. If reality is a simulation, it might have a fundamental resolution, much like a digital image. Researchers are looking for signs of this by studying the behavior of particles at the smallest scales. Another approach involves searching for mathematical patterns or repeating sequences in the fabric of reality that could hint at an underlying code. While these experiments are still in their early stages, they represent a bold attempt to uncover the truth about our existence. As we explore these potential pieces of evidence, it's important to remember that the simulation hypothesis is still a theory, one that challenges us to think beyond the boundaries of conventional science. Whether or not we're living in a simulation, the search for answers pushes us to question the very nature of reality itself. And with that, let's turn to the final piece of the puzzle: the future of the simulation hypothesis and how advancements in technology and science might bring us closer to proving or disproving this mind-bending idea. As we look ahead, the future of the simulation hypothesis holds both excitement and uncertainty. Advancements in technology and science are rapidly pushing the boundaries of what we once thought possible, and these developments could bring us closer to answering the ultimate question: are we living in a simulation? One area to watch is the field of quantum computing. These powerful machines, capable of processing information at speeds far beyond traditional computers, might one day allow us to simulate entire universes. If we can create such simulations ourselves, it could lend credibility to the idea that our own reality might be a product of similar technology. Another promising avenue is the study of fundamental physics. Scientists are already probing the smallest scales of existence, searching for signs of a pixelated universe or mathematical patterns that could hint at an underlying code. As our tools and methods improve, we may uncover evidence that either supports or refutes the simulation hypothesis. For instance, detecting anomalies in particle behavior or discovering repeating sequences in the fabric of reality could provide crucial clues. Artificial intelligence also plays a significant role in this exploration. As AI systems become more sophisticated, they could help us analyze vast amounts of data from experiments and observations, identifying patterns or inconsistencies that human researchers might miss. Some theorists even suggest that AI itself could become advanced enough to create simulations indistinguishable from reality, raising the possibility that we might already be living in one. Meanwhile, philosophical debates and thought experiments continue to shape our understanding of the simulation hypothesis. As we grapple with questions about consciousness, free will, and the nature of existence, these discussions could lead to new insights or even breakthroughs in how we approach the problem. The intersection of science, technology, and philosophy makes this one of the most fascinating areas of modern inquiry. While we may not have definitive answers yet, the pursuit of the simulation hypothesis is driving innovation and inspiring new ways of thinking. Whether or not we ultimately prove that our universe is a simulation, the journey itself is transforming our understanding of reality. And as we continue to explore, one thing is certain: the future holds endless possibilities for discovery. As we wrap up this journey through the 30 ways the universe could be a simulation, let's take a moment to reflect on the most compelling ideas we've explored. From the pixelated nature of reality at the quantum level to the eerie precision of mathematical laws governing our universe, the evidence, or at least the hints, are hard to ignore. The simulation hypothesis, popularized by thinkers like Bostrom, suggests that the odds of us living in a simulated reality might be higher than we think. And when you consider phenomena like quantum entanglement, the holographic principle, or even the Mandela effect, it's hard not to wonder if these could be glitches or features of a grand cosmic program. We've also delved into the role of artificial intelligence, the fine-tuning of the universe's constants, and the possibility that our consciousness itself might be a form of code. Each of these ideas, while speculative, offers a fascinating lens through which to view our existence. And while we may not have definitive proof yet, the pursuit of these questions is reshaping how we understand reality, consciousness, and even our place in the cosmos. So, what do you think? Could we be living in a simulation, or is this all just a fascinating thought experiment? The beauty of this topic is that it invites us to question everything we know or think we know about the universe. Whether you're a skeptic or a believer, the conversation is far from over. Share your thoughts in the comments below, and let's keep exploring this mind-bending idea together. Don't forget to like this video, subscribe for more deep dives into the mysteries of the cosmos, and hit that notification bell so you never miss an update. Until next time, keep questioning, keep exploring, and remember, reality might just be stranger than we can